Okay, so look at problem number 16, and so let's do our conditions for two proportions. All right, and so does it say here anything about random? It does, so random is stated. And then the other one is 10%. And so what do we know about 10%? And we have 4,673 plus 4,502 is less than 10% of all. Can I say people from the United States? It doesn't say. Okay, I'll just say all adults, okay? Okay, and then remember we have the word independent groups. You guys, it's been a long time. Independent groups. And so we say that the one group doesn't influence the other group. So do you see that we meet the first three conditions? All right. It's the last condition that I want to talk about. So I'm going to erase this all. And remember, it's because it's proportions, it's going to be success fail. That's how we determine whether or not the group is big enough. Okay, and so I do the woman, and I do the males, and it's n times p hat is greater than 10, and n times q hat is greater than 10, n times p hat is greater than 10, and n times q hat is greater than 10. All right, so I mean, we could do the proportions, but do you see that we have 40 females? Oh, we have a total of 40 females, 38. Silly Schwartz. And so if we have 38, then that means we have 2. Okay, but what do we know here about 2? 2 is not greater than 10. All right, so we have problems there. And then here we have, for men, we have 27 is greater than 10. And 3, and then was it 23 is greater than 10. So the men are okay. It's just this right here. Okay, so they say it's not valid. So we know it's not A. We know that it's not B. Because the people who favor the band is greater than 10 in both groups. Okay, this is not true. Because of the relative size of the proportions and samples, a two-proportion test would be valid. That is not correct, so the answer is E. Would not be valid. Okay, so for number 17, I read it through, and it has a sample size of 40. So that means we're going to divide by the square root of 40. So this is out, and this is out. Okay, so let's talk about the two differences of this. Remember, and this is on your formula sheet, that is stats minus parameter. Okay? And the stat is a sample of is the mean of our sample. Okay? And that is this guy right here. So he comes first. So the answer is A. Okay, so they tell us that for a one-sided it is 10, and then we have for a two-sided. Remember that when we have a one-sided, alpha is all here. When we have two-sided, alpha is here and here. And so that is why when we have HA of a not equal to, we have to do 2 times the probability. So if we have to do 2 times the probability for a two-sided, 2 times 0.10 is 0.2. So the answer is B. Okay, so let's here talk about standard deviation when we have random variables. And remember, we have to go up to variance, and that is why they told us that the variance is this. So what they want us to do is the variance of x1 minus x2. And what happens when we subtract? That's going to be the variance of x1 plus x2. Okay, So the variance of x1 plus x2 is 35 over 12 plus 35 over 12. And you know, this is why we always add in our standard deviation when we have two guys. Oops, I'm sorry, I shouldn't have done the square root. I goofed. So it's going to be 35 over 12 plus 35 over 12. So what do we know? That the standard deviation of x1 minus x2 is equal to the square root of the variance of x1 minus x2. So the answer is going to be the square root of 35 over 12 plus 35 over 12. So the answer is C.